Welcome to the Explainer. Today we're going to dive into a hidden world that's all around us, and even inside of us, that we literally never get to see.
So let me just ask you something right off the bat. As you're sitting there right now, are you, your body, physically glowing? I mean, are you emitting light into the space around you?
Well, the answer, maybe surprisingly, is yes, you absolutely are. Right this second, your body is putting out its own personal glow, bathing you in a light that is completely invisible to your eyes. So, what is this invisible light?
And you know, this glow isn't just unique to us. It's actually part of a much bigger story. An invisible light that fills our entire world. All of it governed by a pretty fundamental rule of the universe.
And that rule is really simple. Anything, and I mean anything, with a temperature above absolute zero, we're talking everything from an ice cube to a star, is constantly throwing off energy as thermal radiation. It's like the universe's constant silent background hum. And what's so fascinating is that the kind of light something emits depends entirely on how hot it is. You can see it right here. Cooler stuff, like us, glows at these longer, lower energy wavelengths. Think infrared. But as things heat up, say like the filament in an old light bulb, they start to glow in shorter, more energetic wavelengths that we can actually see with our own eyes. So here's the kicker. Because we live at these cozy, Earth-like temperatures, our natural glow, the light that we are all emitting right now, falls squarely in the infrared part of the spectrum. We are, for all intents and purposes, infrared beings. Now, of course, this isn't just happening randomly. There are very specific physical laws that govern this whole infrared world. So let's take a look at the rules of warmth.
The big one here is something called Wien's displacement law. Now, don't let the name scare you, and you don't have to worry about the math. What it does is create this beautifully simple connection. You tell me how hot something is, and this law will tell you the exact color or wavelength of light it's shining with most brightly.
Let's make this real. Okay, if we take a nice, pleasant room temperature, let's say 27 degrees Celsius, and we plug it into Wien's law, it spits out this number, 9.6 micrometers. And this just perfectly illustrates the point. That wavelength is deep in the infrared part of the spectrum. That is the peak glow of a comfortable room. Okay, so temperature explains why we glow. But there is another crucial piece to this puzzle, and it has to do with what we're mostly made of, water. What is it about water that makes it so special in this invisible infrared world? Well, it all comes down to the water molecule itself. See, water molecules are constantly jiggling around, vibrating, stretching, bending, and the amazing part is that the natural frequency of these little dances is a perfect match for the frequencies of infrared light. It's like they're tuned to the exact same radio station. This resonance is what makes water so incredibly good at both absorbing and emitting infrared radiation, and that's why it's such a huge player in our thermal world. The fact that we're all glowing in a light that we can't see brings up a pretty fascinating question. Why can't we see it? To find the answer, we kind of have to imagine what vision might be like on a totally different world.
You know, a core principle of evolution is that senses adapt to whatever is most useful. You don't evolve to see things that aren't there or, just aren't important. Vision tunes itself to the most abundant and information-rich light in its environment. And for us, that's the light pouring down from our sun.
And this chart just makes it so clear. Our sun is hot, right? About 5,800 Kelvin. So its peak light is what we call the visible spectrum. But just imagine a planet zipping around a much cooler star, like a red dwarf. That star's peak light would be in the infrared. So any life evolving there would find infrared light to be the most useful, the most abundant source for seeing. Their visible light would be our thermal light. But this isn't just science fiction. The question is, has this actually happened here? Has any life on our own planet evolved the ability to tap in to this invisible infrared world? Oh, absolutely. I mean, pit vipers famously use those pit organs on their faces to see the body heat of their prey in total darkness. Vampire bats use infrared sensors to find the warmest, most blood-rich spots on their targets. And get this, even some beetles can detect the infrared radiation from forest fires miles away, which helps them find the perfect spot to lay their eggs. But here's a really crucial distinction. These animals are sensing heat. They aren't truly seeing it like we see light. Creating a true thermal eye is incredibly difficult, especially for a warm-blooded animal. I mean, think about it. The eye itself is warm, so it would be constantly blinded by its own glow. The pit viper's special organs are this really clever workaround. They separate the heat sensor from the rest of the body to get a clearer picture.
So, this whole idea that our vision is just one little slice of reality, it really opens up a much, much bigger picture. Let's zoom way out and look at life's full sensory spectrum.
Just look at this incredible range. I mean, at the very bottom, we can sense gravity, a frequency of basically 0. Sharks can sense the tiny electric fields from their prey's muscles. Hearing, across all species, goes from the super deep infrasound that elephants use all the way up to the ultrasonic clicks of bats. And then there's vision, way up there in the trillions of hertz.
When you put it all together, life on Earth has evolved to sense frequencies across 17 orders of magnitude. That is a staggering, almost unimaginable range of information that the universe is offering up, and somehow life has found a way to listen.
So what does this all mean for us, for how we experience the world every day? Well, it means our perception is really just one version of the story. We're all basically looking through a tiny keyhole on reality.
We tend to think that what we see is reality, but it's not. Our senses are not a perfect window. They're more like a set of biological filters, tuned over millions of years of evolution, just to help us survive on this planet under this star. We are totally blind to the infrared glow of our own bodies, to the secret ultraviolet patterns on flowers that bees see so clearly, and to the invisible electric fields that guide a shark through the ocean.
And that's really the ultimate takeaway here. Our reality is custom-made. What we perceive as the whole universe is just a tiny sliver of the full picture, a narrow band of information perfectly tailored to our evolutionary needs. And that leaves you with a pretty profound question. What other glows, what other vibrations, what other hidden realities are all around us right now, just waiting for a different kind of sense to perceive them?